All right, so where were we? We're doing Erlang. We're going to review some stuff that we did last time first. And that means here we are in our Erlang shell. And for those of you who don't know what Erlang is, it's a language that was made to really specialize in parallel and concurrent programming. It was made by Ericsson, a Swedish company, in around 1986. And it is related to the virtual machine that runs Erlang stuff called Beam. And Elixir also runs on it. Gleam runs on Beam, and some other languages. So why use it? If you want to do massively concurrent stuff, WhatsApp, Discord, they use it. I forget the other companies um, as part of their core infrastructure. All right, so we learned list comprehensions before. Those look like this. That's basically generates lists. You give it some list, and it generates, generates a list. You can then multiply it or do something with it. 2.5 times x. So there we go. We can put these things inside of tuples. And now we have the new number and the old number for each one. Probably looks cleaner if we do this. 2, 1, 4, 2, 6, 3. Yeah, I think I got that part. And then we also learned bit syntax. So if you put if you put the base in front of the hash sign, it tells it the base, and then you give it the encoding, it'll print out the thing in decimal afterwards. So FF is 255, and that is equal to base 2, 1111, 1111. And we can even say that by doing equals. There we go. And we learned bit syntax that we can put this within this bit, this thing that holds like just generic binary data. So I think what we can do here is trying to remember what the syntax for this was. I think we put in here the thing we want to put in, and then we say how many bits it is. "24 bits. Is that right? I think that's right. And it outputs the binary data, but it also is a string, so that's how that works. If I make this the number 1, it won't print it because it's not a printable version of it, so it'll say 001. This is how many bits you're putting it into, and here's the thing, the value that's going into it. So I think we can also destructure that into something like red, green, RGB, red, green, blue. And now blue should be 1. Yeah. And we can make red 255. Oops. Yeah. We have to clear everything. And now red is 255. Erlang will not let me reassign what red is, so when I changed it, it gave me an error. I think that covered what we learned last time. Let's just check. Bit syntax, binary comprehensions. Yeah, that one was a little bit different. So in the way that list comprehensions look like, this binary comprehensions have this on the outside, and then on the inside, God, I can't remember. I don't even know. I should know. All right, let's see. I see it's just making a list. Yeah, that makes sense. Okay. So here is, no, here is the list, but the binary comprehension. So we have the syntax where we put in the thing we want to build. There's the thing we want to build. And now we can assign it from a bigger binary a list of, yeah, so it's a list of binary syntaxes. So first let's create a list of binary syntaxes. So let's see, that looks like this. Um, I had one of these up here already. Now I just put this in. I just call this 0. Well, some color, red, green, blue. I can make a list of these. It's not very interesting, but we have a list now. And now I can do my binary comprehension where I will construct a red, green, blue. But now I need to get RGB in here. So I guess, what do I do here? Like, oh, this was not a binary. This was a tuple of RGBs. Let me just construct one. So I do RGB, and then I give it a list of tuples that have RGBs, like 255.0.0, and then 0.255.0, and you can guess 0, 0, 255. There we go. Okay, so what's going on? I have a list here. It's a list of tuples, of 3 tuples, so it has 3 values in each one, red, green, blue. And then I deconstruct it to RGB values, so it pattern matches, and R will have the first value, G the second, and B the third. And then it will construct this binary comprehension, this whatever you call it, where it takes each one 255.0.0, then adds 0, 255.0, and then does 0, 0, 255, and creates this one binary stream of all of those things. And obviously I can do the same thing where I add a clause here where I can say, like, I don't want anything, I only want ones where red is equal to 0. And so you can see this one is red as 0 and this one's red 0, but we dropped the first one. All right. We did modules. I'm not going to review that. I'll review that next time I do a stream. So let's learn. Really, the binary stuff is the hardest. Syntax and functions, pattern matching. Now that we have the ability to store and compile our code, we can begin to write more advanced functions. Those that we have written so far were extremely simple and a bit underwhelming. We'll get to more interesting stuff. The first function we'll write will need to greet someone differently according to gender. In most languages, you'll need to write something similar to this. Greet if gender is male, then hello Mr., otherwise female, then Mrs. Else, we just say hello because we're not sure what gender they are. With pattern matching, Erlang saves you a whole lot of boilerplate code. A similar function in Erlang would look like this, greet. So you basically define greet 3 times. The first time it's pattern matching male and female, and then it's basically whatever else you pass in, it's going to try to say the same thing. I'll admit that the printing function is a lot uglier in Erlang than in many languages, but that is not the point. The main difference here is that we use pattern matching to define both what parts of a function should be used and bind the values we need at the same time. There was no need to first bind the values and then compare them. So instead of the whole if, else, we just write the function in order to get this similar results, but in a much more declarative style. Each of these functions, function declarations, is called a function clause. Function clauses must be separated by semicolons. I didn't notice that. Here we have semicolons. And together they form a function declaration. So this is a function declaration, and this is a function clause. A function declaration counts as one larger statement, and it's why the final function clause ends with a period. It's a funny use of tokens to determine workflow, but you'll get used to it. At least you'd better hope so, because there's no way out of it. Note, IO formats formatting is done with the help of tokens being replaced in a string. The character used to denote a token is the tilde. Some tokens are built in, such as tilde n, which will be changed to a line break. Most other tokens denote a way to format data. The function call IO format sn hello includes the token tilde s, which accepts strings and bit strings as arguments, and tilde n. The final output message would thus be hello new line. Another widely used token is tilde p, which will print an Erlang term in a nice way, adding in indentation and everything. The IO format function will be seen in a lot more detail in later chapters, dealing with input and output with more depth, but in the meantime you can try the following calls to see what they do. SN, PN, IO format, tilde, tilde, tilde n, FN. Okay, there's a whole bunch of things here. I don't think we care that much. But looks like we didn't actually test this function, so let's go write it. New greet. Yeah, I don't know how the underscore works here. I'll just do new greet.url. And we learned that, did I put in modules in here? Yeah. Oh, here it is. This part is really important. This is how you declare a module. And that's basically like the package you're in. So hyphen module, and we put the name in here, and it has to match the name of the file name, just not with the ending, I think. And then I think we can just put functions. So where is our function section? I just pass it.
What the? Ah.
Here that goes.
Ça va, non, mais ça surprend un peu quand même.
All right, so we had something called like new greet or something, right? And we want to pass it was the gender, right? So, and then we want to pass the greeting. And what was it like? io.format? Is that the command? IO format, yeah. So I'm making a different version first. Oh, we want the name, right? Tilde s, tilde s, and then tilde n for like new line, and we give it the string replacement where we pass in the gender, we pass in the name. But I've already forgotten that variable names should be capital. And there we go. Why is it not happy with this? Oh, you like it? Want to show it? Can you show it? Look what my girlfriend made. I think you can see it, right? What's the name of it?
Mokona.
Mokona. She just finished.
No.
Well, it's not finished because it probably needs to be colored in, right? White. Hey there. Hello. Nada. All right. Why is my thing not compiling? Oh, because first of all, new greet should match the name. It still doesn't like IO. Oh, it's because it needs to be colon. I'm so bad with this. All right, cool. And then let's also export our function, which needs to be new greet, which takes in 2 parameters. So we do this. And now we are good. Oh, I'm so glad you're doing well. Okay, so we wrote a new function called newGreet. Let us now run it. Compile newGreet. Okay, now that runs. Now I should be able to do newGreet.newGreet. Why isn't this working? Oh, it's not. It's newGreet new greet, and I gave it like Mr. Smith. Hello, Mr. Smith. That's not the comma went in the wrong place, right? Hello. There, that should be better. You greet colon, you greet Mr. Smith. There we go. Or we can do Mrs. Smith. Hello, Mrs. Smith. Didn't recompile though. I didn't run the. Here we go. Hello, Mrs. Smith. Okay. And why is the okay there? It's because that was the last return statement from IO format. Okay, cool. But we need something better than this. We want to use atoms here. And we will basically say gender can basically be either Mr. or we can do male, female. Um let's be inclusive. X. And so if the gender is male, then we say hello, Mr. And now we don't need this thing here, right? And then we have female. Oops.
Bobo, cet homme nous qui.
We'll do Ms. Okay. Oh, we need semicolons here. And then the last one.
T'as la référence, Bobo?
We are saying it doesn't matter what it is. It could be X, it could be whatever.
Tom Nook. Tom Nook, c'est un personnage de Animal Crossing. C'est celui qui te fait des prêts
There we go.
à gogo pour agrandir.
And then here we've got to put a period. So now when we run it, we compile it. Now we can do new greet, and then we can pass the atom, male, and then we give it the name. So it says Mr. Oops, I could have just Ms. We do X. And it just says hello Smith. All right. So we wrote that one. We've written that one. We've written that one. Wow. It can get more complex. You can pattern match on list to get the heads and tails. Let's do this. Let's see what they're trying to do. Oh, it's just trying to get us to write our own heads sort of thing. Let's just put this inside of a new greet. So we're going to make a function call, our head version. And inside of it, like you can imagine being passed a list, right? And then you would call head L, and this would be the end of it, right?
Il a un loop.sac.
There, we have to export our function. It takes one parameter, so we put one. Now I run this again. Maybe I should just put it here. Compile, new greet. And now I run new greet head, and I give it some list. And it should just return the first item, 1. But now we can do pattern matching instead and say what a list really is. Is a head followed by the rest. Like, this is really rest, right? Tail. But we don't care about the tail, so we're going to ignore the pattern matching. We're not going to use the variable that matches there. And then we just return H. Does this make sense? So that means when we call head 1, 2, 3, you get the idea, right? It's going to break this up, and the 1 goes to head and the rest goes to here. We learned that in the list part, so you can go back to that episode, that video if you need a refresher. So let's compile this again. And then we call head, and it should work exactly the same way. So that's not super interesting, right? But yeah, like notice that if I do H like this, I can just put this in here, doing like 5, 6, 7, and H now is going to be 5 because it matched that. In the same way that I can put T as the rest, and T is going to be the list 6, 7. All right, so now it looks like they're trying to declare a second, like the second item in a list. So let's make that second. So the first item is going to be the head, and then you end up with the second item. So let's call this let's call this element 1, right? And then if you break this up again, this is tail, right? That's what we've done before. And we can return E1, and this is basically the same function as earlier. But now, since we know tail is always a list, right? It could be the empty list, but assuming there it's more than 2-item list, then we can break this up again too. So we can give it some space so you can really see like this is a list now too. And it too has a head, we'll call it E2, and a tail, right? So you see, this was the first item, this was a list, but we've just broken it up even more. Let's even it out a little bit. And so we can return E2. And now it's saying no one cares about E1, so we put a underscore there, we put an underscore here, we save it, and now it doesn't complain anymore. And now we have to add second to the list of stuff we are exporting. It takes one parameter. Now this should be good. So we're going to compile again. And now I should be able to call new greet second, pass in a list, and it should give me 2. There you go. Yeah, so if we only give it 2 items, then we fail because it basically couldn't find a function clause that matches because it failed here, right? Because basically we have to give it one that matches. So the one that matches is where there is a first item, and then the second item is the empty string, right? We don't care what the first item is either, but we know that it basically means it's an empty string, empty list, right? So it only has one item. That's what we're declaring here. If that's the case, then second should be, I don't know if they have a null variable, nil maybe? I think there's a nil. Um, let's compile again. Now when I pass in 1, we get back nil. Oh, the other thing we can do is just like return error, right? Like, yeah, now we get an error that we can match against. Or if we give it a valid second, it still works with a 2. All right, so I think that's pretty much what we wrote. Um, okay, what is it saying now? Let's concentrate on more pattern matching. The concept of free and bound variables we discussed in starting out for real still holds true for functions. We can then compare and know if 2 parameters passed to a function are the same or not. We'll create a function same, which takes 2 arguments and tells if they're identical. All right, so let's make is same. And if we pass in 2 of the same things, then they would be equal to each other. Return true. Otherwise, is kind of, they always go in order here. Um, they always go in order, so it's always going to try this one first and this one second. So this one will match, and it'll be true, and this one will, if it doesn't match, then it goes here and it'll say false. I think we don't have, well, we can try it real quick. Those are the same. These are not the same. That's not the same. These are the same. And if we add one more, if we remove the item, they're not the same anymore. There we go. Unbound, bound values. Let's see what this is talking about. If this game of musical chairs was Erlang, you'd want to sit on an empty chair. Sitting on one already occupied wouldn't end well. Joking aside, unbound variables are variables without any values attached to them, like our empty chair. Binding a variable is simply attaching a value to an unbound variable. In the case of Erlang, when you assign a value to a variable that is already bound, an error occurs unless the new value is the same. Yeah, so x is equal to 5, and then I can do something like b is equal to 5 or 4, and I can say x is equal to b plus 1, x is equal to b plus 1. And it's fine with that because the pattern matching is saying this is allowed since x is already the same thing. It's basically not rebinding what x is, right? But if I try changing what x is, then it's going to say no, x is 5. 5, that's like saying 5 is equal to 6, and that's not going to work. But 5 is equal to 5, you can do fine. Um, let's kind of skip some of this stuff. Note that this function can effectively take any kind of argument whatsoever. It works for any data type, not just lists or single variables. As a rather advanced example, take the following function, prints a date, but only if it is formatted correctly. Yeah, it's saying it needs a date. Okay, so let's break this down. This is worth doing real quick. Valid time, and valid time is taking in a tuple, year, month, date, right? And then it's taking, that's the first parameter is a tuple, year, month, day. And then the second parameter is hour, minute, second, right? Let's make time fully. That's good enough. Hour, minute, second. Hour? Now let's do hour. Um,
Tuto.
yeah. Let's keep it this way. I realize it's a little bit different in a couple of ways. And then let's say we do something like IO format, and we say year is, let's print out the year. Year slash month slash day, right? And we say time is equal to hour. Oh, is P printing out the, let's do it like this. Sorry, I'm typing slow here. And we have to give it the list of things, year, month, day, followed by hour, minute, second. I think this is right. Valid time. And it takes in 2 parameters here, right? 1, 2. So let's try running this now. Valid time. Press to compile. Then we do new greet, valid time. And it needs a tuple of year, month, date, let's say, followed by hour, minute, second. Oops. No, it needs to be a string, so we have to replace these. There we go. Date is year, day, year, month, day. Time is 10:25:55. I should probably have printed new line at the very end there. Why am I stuck? Why can't I move? There we go. Okay. Some of you probably don't like this month day thing. And now what they're doing here is they're actually like assigning this whole thing as date. And they're actually assigning this whole thing as time. So it's a little bit like if you had just started with valid time is date, comma, date, comma, time. It's like saying that. But you're also deconstructing at the same time. So now in the body, you can either use date or individual variables, right? Um, so now I should be able to print out date is equal to, I'll say date is equal to this and little date is equal to this. So now we'll pass in the big date. And time we're just not going to use right now. Let's see what happens right now. All right, date, and you can see that it prints out the tuple, but when we break it out individually, you can see that um, it used the individual formatting that I gave it. So this is kind of nice when you know you're going to have to use the high level one, like the bigger one and the small one, both in your body. Um, and that happens if like you need to use this, but then some other API call or something you use later just needs the whole thing. Um, yeah, so if we make another version of this where it says something doesn't match, we have two parameters but they don't match for whatever reason, then we can say something like invalid invalid date time format, right? Keep forgetting the semicolon. So this is fine, but if I add an extra thing in here, it notices that it can no longer pattern match with the three items here because now I passed in 4, so it falls under this one here. Now this won't save us if I pass the wrong number of parameters. It'll just tell me that's wrong. Um, yeah, so now we're going to add guards. Guards, guards, guards. So what this doesn't do is, what if I pass in, instead of, I still pass in 3 things, but I pass in foo as the last item. You can see that it prints out foo here, which is not at all what I want. I want to make sure that all of these things are numbers. So how are we going to do that, right? So you can see that there's this keyword when, and we can use that. So in our example, what this means is we can say when is number y, oh my god, and also else. How do we do this then? Oh, it's semicolon and there's a comma. So how does this work? The comma acts in a similar manner to the operator and also, and the semicolon acts a bit like or else. Both guards expressions, so I basically want comma because I want and also. So I want to say is number M is number D is number hour is number minute is number second. I think that's right. And then we compile this. Now if I pass in foo, it goes to the invalid time format because it notices that this is not a number. But if I gave it a number, notice that it works now, right? The same thing goes for any of these things. What else did we learn? We learned if we pass an atom, that will fail also. So, or, a list, that will fail. All right, so we kind of am going through this quickly. We've learned this. I've compared comma and semicolon in regards to the operator and also and or else. They're not exactly the same though. The former pair will catch exceptions as they happen, while the latter won't. What this means is that if there's an error thrown in the first part of the guard, x is greater than or equal to n, semicolon, n is greater than or equal to 0, the second part can still be evaluated and the guard might succeed. If an error was thrown in the first part of x is greater than or equal to n or else n is greater than or equal to 0, the second part will also be skipped and the whole guard will fail. So these things will kind of like, especially with the or else, right? Because you want it to continue because it can still be right. I'm guessing that with the and also, if there's an exception, it will just fail anyway because what does an exception mean? Probably means it's false, right? However, there's always a however. Only and also and or else can be nested inside guards. This means A or else B and also C is a valid guard, while A semicolon B comma C is not. Given their different use, the best strategy is often to mix them as necessary. Hopefully you don't need too many nested guards. That sounds kind of complicated. What the if? If acts like guards and shares guards syntax, but outside of a function clause's head. In fact, the if, I read that really funny. In fact, if clauses are called guard patterns. Erlang's ifs are different from the ifs you'll ever encounter in most other languages. Compared to them, they're weird creatures that might have been more accepted had they had a different name. When entering Erlang's country, you should leave all your know about ifs at the door. Take a seat because we're going for a ride. So we're going to take a look here. Fine. If 1 equals 1 works, end. If 1 equals 2, semicolon, 1 equals 1 works, end. If 1 equals 2, fails. All right, let's try this out. I'm not gonna type that in. I'll just copy it. Okay. It's giving us warnings, but I think that's part of the exercise. So let's run it. I can't. I forgot everything. Um, yeah, we got the same thing. No true branch. So let's see what happens. If 1 is equal to 1 works, end. If 1 equals to 2 or else 1 equals to 1 works, end. If 1 is equal to 2 and also 1 is equal to 1 fails, end. And then none of them were true, right? Uh-oh, the compiler is warning us that no clause from the if on line 12 will ever match because only guards the only its only guard evaluates to 4. False. Remember, in Erlang everything has to return something and if expressions are no exception to the rule. As such, when Erlang can't find a way to have a guard succeed, it will crash. It cannot not return something. As such, we need to add a catch-all branch that will always succeed no matter what. In most languages, this would be called an else. In Erlang, we use true. This explains why VM has thrown no true branch found when it got mad. So, I guess we add this function. Did I not copy it? Okay. If n is equal to 2 might succeed. True always does. So this is part of the same if. So now, I guess we can call new greet. Oh God, and if we pass it 2, it should succeed, right? Yeah. But if we give it anything else, it'll just return true. Always does. Yeah, true always does. Yeah, exactly what we did. So if we look back on the het fine, um, it just needs like a true clause, right?
Ah, merde. Je comprends.
Is that how it looks? Yeah, something like this. Like, I don't know what this function is trying to say, but I'm just gonna make it compile. Okay. Still doesn't like it. Warning, this clause cannot match because a previous clause at line 34 also matches. So 34 and 36. Ah, so I maybe don't need this. Let's see what happens. "39. This clause cannot match because 39 can't match because of 37. Oh, so I don't need this either because this is going to be trivially true. So saying if this is and also this.
C'est long. C'est très long.
This clause cannot match because its guard evaluates to false. 40.
Le remplissage à faire.
If this
J'ai plus que le remplissage à faire. C'est long.
this clause cannot match because its guard evaluates to false. Because this is trivially forced, it's never going to match. Okay, so it has nothing to do with trying to fix it. It's just bad because this is always going to fail. So it's saying like you shouldn't have this.
Puis un côté un peu frustrant parfois dans le point cross, c'est que j'aime bien le process de. C'est le fil quoi.
Wonder
Mais
do I even know what I'm doing? Yeah.
t'as un grand fil, c'est un peu chiant de tout passer, et en même temps t'as envie d'avoir un grand fil parce que t'as pas envie de recommencer toutes les 5 minutes, mais en même temps
All right,
c'est pas
well,
non plus bon voilà quoi, c'est pas non plus hyper agréable. Bref,
hi there.
de la vie quoi.
Sherificals. Or Sherificles. I gotta do more on Nix. I've been thinking about it. It seems like a lot of people come in from Nix, so might as well do some more on it. I use it for my OS, so I have several computers. I use Nix on on my main laptop. And this is running Nix under WSL Wizzle. Okay, so now if we test this new function, blah blah blah. What is this doing? Help me animal talk is equal to. Alright, so it's basically saying make talk the thing it's gonna say, right?
Un gros nœud là, j'ai pas vu.
I would probably make something called like animal sound. And we're gonna pass in an animal, right? And then we're gonna say if animal is equal to cat, then we're going to say meow. Yeah, we use semicolon here. And we say if animal is equal to dog, then say bow wow. It should be woof, right? Let's add a duck.
Ils meurent. Et puis moi jamais leurs parents.
Quack quack.
Oui, ça m'arrive.
And that'll be, and then we need a catch-all.
Je crois que c'est super le technologie.
So we say true,
C'est quand même une meuf qui
and
bien
you
fait
say
hein.
What's like if you don't know what's like the most generic animal sound? Grr,
Les mecs,
right?
en 3D.
Okay. Now I can test animal sound.
On vit dans le futur.
Duck, dog,
Futur volant,
rabbit. Grr. um,
tout ça. Tard d'avenir, ces voitures
but
volantes.
they wanted a function that returns like um why is it called help me animal? Animal speak. So we pass in an animal
Ah, mais c'est marrant parce que je pense que tu demandes à des enfants aujourd'hui, je pense pas qu'ils
and what we're
sauront.
going to do is return
Ce serait intéressant, je serais curieuse de
um
savoir ce que dira un gamin aujourd'hui
why
apprendre
are
ce
they
mot.
returning animal says we'll do the same
Qui
thing. So we'll say animal with a tuple
Qui
and we're going to say says and then we'll add in animal sound animal.
Là, l'archive de Lina. Non. Ah,
And our guard
non,
here
tu vas faire un
is
truc de dingue.
when is atom animal because it has to be an atom. These all are atoms. And we can do the same thing.
Le Bob de l'Ordoline. Ah oui, 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 ça me
Okay.
parle aussi celui-là.
By the way, how are you liking Nick so far? Terrifically.
Quelqu'un avoir un profil
So we have animal speak now. And if we give it something that's not, it won't try to match it. And we say dog, they'll say dog says bow wow. I feel like I have to fix this quack quack. I just realized this is the English spelling here. Okay. What the if? Wait,
tel qu'imaginé dans les années 60.
did we make a function
Eh
called
oui,
what
c'est
the
ça.
if? Oh, that was here.
En 2000, tel qu'imaginé dans les années 60.
It hurts. It hurts says,
Vous pouvez
right.
m'appeler un humain dans 2000 tel qu'imaginé dans les années 60.
You might be one of the many Erlang programmers wondering why true was taken over
Les voitures
else
volantes.
as an atom to flow control. After all, it's much more familiar. Richard O'Keefe gave the following answer on the Erlang mailing list. I'm quoting it directly because I couldn't have put it together better.
Mais c'est ce que je dis.
Great, I'm glad it's getting easier. It may be more familiar, but that doesn't mean else is a good thing. I know that writing semicolon true hyphen greater than is a very easy way to get else in Erlang, but we have a couple of decades of psychology of programming results to show that it's a bad idea. I have started to replace if this by this.
Je les ai un petit peu trop écoutés aussi.
Which I find mildly annoying when writing the code, but enormously helpful when reading it. So if x is greater than y, then a, else
Maintenant, les
x
têtes que
is
j'imaginais il y a 30 secondes.
less than or equal to y, then b, end. So this semicolon is or else, right? As a guard. No, that's not. I guess it's just really making sure that everything's exhaustive. Else or true branches should be avoided altogether. Ifs are usually easier to read when you cover all logical ends rather than relying on the catch-all clause, right? So it's basically saying, try not to even do this, like don't even have this. All this horror expressed by the function names in what the if is expressed in regards to the if language construct when seen from the perspective of any other language's if. In the Erlang's context, it turns out to be a perfectly logical construct with a confusing name. In case of, if the if expression is like a guard, a case of expression is like the whole function head. You can have the complex pattern matching you can use with each argument, and you can have guards on top of it. As you're probably getting pretty familiar with the syntax, you won't need too many examples. For this one, we'll write the append function for sets that will represent as an unordered list. All right, so what are we doing here? We're going to use a case statement, and let's just try to program this. Looks like we're going to insert something in here. We want to just make sure that um, it's not already in the set. So here's insert, and we have an element. And if it's a list, that's an empty list, then we can just return, I guess we can just return X, right? Because we know nothing's in there. But otherwise, we're returning something and it's a non-empty list. So they call it a set here. So we have two cases. We want to know if it's already in the list. I mean, like, we can just do this with an if statement, right? If member of member x comma set, I'm looking at how, yeah. Then we just return x because we don't need to do anything there, right? And then our other example, which is true, we return x in, but we're adding it to the set. No, this goes in the end. There we go. So obviously we need a member function now. If is x a member of a list of a set, if it's the empty set, then we return false. And then if X matches the head of the list, we return true, right? Otherwise, we don't need rest here, but we'll just make it clear. Otherwise, we have some other head here. We don't care what it is. We have rest. Then we're going to call member rest. Does that seem right to you? There we go. So here, yeah, we don't care what X is here. All right, let's try testing member first. Oops. We cannot call a local in guard. Oh, this one's illegal. Why? I'm a little confused. Am I saying
Yeah.
is this okay? And then can I do is if I'm so confused, why is this not okay to do? Oh, I can only have one statement.
Là, il va falloir que je le couse en fait.
Wait, I'm
Hop,
so I
on peut
can't
fermer.
call this in here. Call to local importer is illegal in guard.
Bah, et là, c'est un
Maybe
peu
that's
beau.
why we need to use case, huh?
Non, c'est pour mettre. Pour bourrer un petit peu, faire un coussin.
Case
Que ça
member
soit sur les lèvres.
X of, and then we have the syntax is true does this. Oops.
Non, j'en ai fait qu'un que j'ai cousu aux extrémités.
False
Mais,
is this.
mais en fait, je suis en train de me dire, je sais pas si j'ai
Okay,
fini
so maybe we that's why we actually use case because we can't use a function within the if clause. So we're calling member X. Right. What I was doing was actually testing member. I could have used list member, but I want to, since we're writing stuff, might as well test it, right? You greet member, we're giving some value for, is that part of 1, 2, 3? No. Is it part of 1, 2, 3, 4? Yes. Is it part of an empty list? No. Okay. I think it works. So now we're going to try to insert stuff. If it's a member, then we don't insert it. If it's not a member, then we add it to the beginning of the set and return the new set. So we'll try doing that. Insert the number 1 into the empty list. Now we have 1. And if I have 1, 2, 3, oh crap. If it's a member already, we don't return the item, we return the set. There we go. Um, and we'll add 4, 4, 1, 2, 3. I think it works. True set, false X set. Yep, that's what we have also. Perfect. Um, beach temperature, temperature of, if it's Celsius, da 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 da. Oh, it's just telling us like, oh, I just thought of like in member. Yeah, X can be anything. Just always make sure that we have a type for the list, right? Because you can see this is always a list, so you can't pass it anything else. Here is kind of tricky. You can pass it something that's not a list, but we can just make it really clear. That's the guard I would probably add here. I'm not going to type this. This is stuff we all learned already. Which to use? Which to use is rather hard to answer. The difference between function calls and case of are very minimal. In fact, they are represented the same way at a lower level, and using one or the other effectively has the same cost in terms of performance. One difference between both is when more than one argument needs to be evaluated. Function A, B can have guards and values to match against A and B, but a case expression would need to be formulated a bit like case AB of pattern guards. This form is rarely seen and might surprise the reader a bit. In similar situations, using a function call might be more appropriate. On the other hand, the insert function we had written earlier is arguably cleaner the way it is rather than having an immediate function call to track
Le
down a
F, c'est
simple
pas grave.
true or false clause.
Ça me rappelle de la
Then the other question is, why would you ever use if given cases and functions are flexible enough to even encompass if through guards? The rationale behind if is quite simple. It was added to the language as a short way to have guards without needing to write the whole pattern matching part when it wasn't needed. Of course, all of this is more about personal preferences. Da 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 da. So let me just go back at the if one. Yeah. So when they say it's like guards, it's basically like adding it over here. Yeah, and you can't call functions there. So interesting that it's not like a very complete if statement, right? Um, well, we're done. I'm just reflecting in my head. The next, congratulations if you made it this far. The next one is types, dynamic, strong typing. We won't cover this today. You've seen me use some of these today.
Oui, c'est un fouille. Sorti de mes douilles.
It's a short chapter, so this will be fun.
Trop miel.
Let's see, I'm guessing we've been on for an hour and 25 minutes. Great. It's the weekend. I do shorter streams on weekends because I don't want to bother my partner. Right?
Comment?
I do short streams because I don't want to bother you on weekends. I don't think she's convinced.
Tu peux continuer si tu veux.
It's okay. I want to take this Erlang thing and like make a chat server, I think, chat server out of it, see how it works. Maybe like have it interoperate with Elixir at the OTP level and see what happens. All right, so we're gonna stop here, at least with this stuff. I want to see like, so what's a good Commodore 64 emulator? Vice. Does Nix have the Vice emulator? Oh, look at that, it does. Commercial. There's a Vice manual. Download distribution. And then what? Like, how do you, is there like, oh, holy cow.
Bonne nuit. Bonne nuit.
What's it called? Vice? The fuck? What does this install? Oh, oh wow. I can't type in this thing though. What? I can't even click on the. Nothing's working. Well, that didn't work. X64SC, the accurate version. Maybe I need this. Oh, that worked. Let me. Maybe it's when I have OBS grab it that causes the problem. Yeah. Oh no. It's just like when OBS is doing it, it's like just super slow, maybe? Notice like. So maybe if I do this, I can't like capture. Um, Probably need to figure out how to do desktop.
C'est un petit peu le même genre de trans dans lequel je suis.
Let's try it.
J'arrive pas souvent.
So when I'm not, it's fine when I'm not sharing it on OBS, but if let me try desktop and see what that does.
Allez, j'ai fini les oreilles. Hop. C'est bon ça. C'est bizarre parce qu'on dirait qu'il a un chapeau. Mon Mokona, il a un chapeau de Mokona. C'est un peu bizarre.
Oh, as soon as I switch to anything where it's capturing this, it screws up.
J'ai pas essayé un truc aujourd'hui. Oh là là.
It's really interesting. Let's ask ChatGPT. Instead of try game capture, that's a lot of things to try. All right, let's see. I'll run it again. Oops. Now I add a game capture instead. See what happens. Hmm. Doesn't feel like it's gonna work. No. I guess I can just capture. No, there's it says full screen application, but this is not full screen. Hmm. Do you see this? Why is now it's not even working at all? Well, maybe Vice is not going to be the thing to use. Oh, there is a full screen option. Let me see. I'll do full screen here and then add a game capture. Hmm, that didn't work. So this must not be real. Okay, that said something else here. In Vice, look for video settings, render output. Switch to OpenGL. That is under video settings. Full screen. Maybe just under settings. Then I see display, synchronization vsync. Turn off vsync. Okay, I can turn that off here.
Ah bah tiens, c'est exactement ce que je suis en train de faire. Du crochet.
Oh, now it's really slow. Double scan, da da da, PeptoPal.
Oh, trop mignon.
I don't see anything here where it says like OpenGL. It is so slow. It's amazing how slow this is. Maybe I'll have to like. Maybe I'll run this in Windows. Let's try running this in Windows. Where was this? Vice? Download? GTK3. All right, let me try. Guess I'll try playing around with this later. I'm not going to make everyone sit here while we do this. As I proceed to make everyone sit here.
Ok.
Wow.
Oh, j'ai vu un
It's
truc.
funny, right? It's like such a simple thing like a
J'ai vu
Commodore
ça, ça m'a
64,
fait
but then when you
tellement.
make an emulator for it, you have like a billion options.
Faire.
I guess because it's like ways to make it different. That is way too much. All right. Anyway, done with Erlang. We got it done. We'll do more